Now, let me introduce myself. My name is Sabrina Tedeschi, and I'm a senior application engineer here at Bentley Systems. And I've been with Bentley Systems for over 12 years. Now, before working for Bentley Systems, I did work in the industry for an architectural engineering firm, and I designed large commercial structures out of a variety of materials, including steel and concrete. So let's talk about today's focus for what we're going to be doing in STAAD.Pro Connect Edition. We're going to be talking about generating load combinations in STAAD.Pro, and we're going to explore this option in the STAAD.Pro Analytical Modeler and also the STAAD.Pro Physical Modeler. The last thing we're going to do is we're going to be talking about seed files in STAAD.Pro. Now, two of these topics that you're seeing on your screen are only going to be available in STAAD.Pro Connect Edition version 22 Update 5. I wanted to make sure that I pointed this out because we have a lot of good enhancements that are happening in Update 5, which actually should be available within any day now. So what we're doing today is I'm giving you a preview of what those commands will be. And then I'm going to encourage you after this session to go to the Connection Center. And as soon as Update 5 is available, I would encourage you to download it if these are workflows that would appeal to you. That being said, let's go ahead and talk about our first topic. Now, I know some of the topics we're going to be doing today are probably fairly familiar to a good portion of you, especially if you are experienced STAAD.Pro users. You've already probably generated load combinations or at least created a load combination in the STAAD.Pro Analytical Modeler. But whenever I personally discuss load combinations, I like to make sure that I start with the basics and talk about the difference between traditional load combinations and also repeat load cases, as this could have a significant effect on your analysis and eventually your design. And of course, you're going to have to think about your code requirements when generating any load combinations in STAAD.Pro. So in STAAD.Pro, we have two different ways of combining different load cases together. Okay, you can create a traditional load combination, or you can create a repeat load case. And it's very important to understand the differences between these two different features within the programs. So a traditional load combination means that you are looking for a set of load results, which are combined algebraically to produce a superimposed sets of results for post-processing. And you can see what the effects of that would be via the graphic on the slide deck right now. Basically, what we're going to do is we're going to take the results of your individual load cases, combine them together algebraically, basically after the analysis occurs. In contrast to that, a repeat load case is a primary load case using combinations of previously defined primary load cases. Now, in a repeat load combination, STAAD.Pro will apply load cases of the structure simultaneously and then calculate their combined results. And of course, this is super important if you're doing any type of second order analysis within STAAD.Pro. If your analysis includes things like tension or compression only members, or any second order effects such as P large delta or P small delta, you're going to want to make sure that you are generating repeat style load cases, because the significance of that is that those load cases will be combined together, and then their combined results will be determined by the program and available. And of course, as we know with P delta, you can experience some additional moments due to those loads being added on the structure simultaneously. So what I'm going to do today is what we're going to show you is, first of all, I'm going to show you how to manually create those load cases, both a traditional and a repeat load combination. And then we're going to talk about how to generate them, how to control your load combination generators as well. We're going to be starting in the STAAD.Pro Analytical Modeler. And as I mentioned, the first portion of this special interest group session may be fairly familiar to most of you. But what we're then going to do is we're going to show you that everything we can do there, we can also now do in the physical modeler. And then eventually I'm going to talk about seed files, which is brand new for STAAD.Pro Connect Edition Update 5, which I know I'm very excited about. So I want to make sure I show you that, because you can definitely use seed files to kind of streamline your process for loading or other modeling features that you might be interested in. So what you can see on my screen right now is I have my STAAD.Pro Connect Edition loaded. Now, again, I am using STAAD.Pro Connect Edition version 22 Update 5. That will be available. It's not actually available yet today, but it will be available, I think, within the next couple of days. So I'm going to encourage everybody to go to the Connection Center, especially if some of these workflows are interesting to you, but I wanted to be able to cover these topics. So here I have my STAAD.Pro Connect Edition screen shown, and I can go ahead and see which version I'm running. In the start screen, I can go ahead and say about STAAD.Pro, and here I can see which version I am running. Again, I'm using an internal build for today's session. In addition to that, I also want to encourage you, whenever you update to a new version of STAAD.Pro, to go to the help area. And if you go to contents, let me pull this over on the right screen, we can go to what's new, and you'll be able to see everything that's added for each individual version. I like to point this out because these are basically our release notes. And this could be helpful. So here, if I go to update 5, I can see in various categories what is new. And we have several different loading features that are new, which is why I chose this as a focus for today's session. Now, that being said, let's go ahead and walk into a model that I've already created, and let's talk about generating load combinations. I'm going to first start with an analytical model, and I'm going to open an analytical model that I've already created. So we're going to be spending our time on the loading page. So if you're new to STAAD.Pro Connect Edition, you've obviously probably noticed that our graphical user interface has been completely redesigned from V8i to Connect Edition. Basically, what it includes now, instead of the menus and toolbars at the top of the screen, we have a ribbon toolbar system, which organizes all of our tools in main categories. You're also going to navigate from the program using this page control area at the top of the screen. And our typical workflow in general is to work from left to right within this toolbar. We're going to be spending our time today on the loading area and within the load and definition dialog, which should automatically become available when you're in this loading tab. Let's go ahead and take a look at my load case details for this model. I just have some basic load cases in my model. Of course, this can be done with however many load cases you might have. So the first thing I'm going to show you is how to create a traditional load combination. This would be a load combination, which is a set of results which are combined algebraically to produce superimposed sets of results processing. Now, a traditional load combination would be completely appropriate for something like a linear elastic analysis, but it would not be appropriate for any type of second order analysis. I like to make sure that that is perfectly clear, because if you need to capture second order moments and effects on your structure, you definitely need to go with the repeat load case. So I'm going to show you the difference. I'm going to show you how to tell within your model which type you have already created to give you some information there. So the first thing I'm going to do is I'm going to create a manual load combination. I'm going to go to the loading tab in the ribbon toolbar, and I'm going to tell the program I want to create a combination case. Now, this combination case automatically creates a traditional load combination. You can name it anything you want. I'm going to say mine is dead load plus live load. And you're going to grab your load cases that you want and adjust their factors. Load case number 1 for me is dead load. I'm going to call this 1.2. Load case number 2 is 1.6. Add, and then close. And of course, you can create any additional load combinations you need to through this manual approach. Now, I mentioned a few moments ago, how do I know if this is a traditional load combination versus a repeat load case? Perhaps I'm using somebody else's model that they created or started for me. The reason I know this is a traditional load combination is because I see the blue C symbol right here. This means this is a traditional load combination. Let's go ahead and move forward. And what I'm going to do is I'm going to manually create a repeat load case. Now, a repeat load case is, I'm not saying a repeat load combination, it is actually a load case. So the process for that is to basically create a load case and then combine your loads together in a repeat load item. Very similar to the idea of creating a new primary load case together. So what we're going to do is we're going to tell the program we want to create a new primary load case, and I'm going to name it anything I want. I'm going to say this is dead load plus live load, and just for good measure, I'm going to say repeat at the end of it. Now, this is already a combination case, so I'm going to set the loading type to none, but we're going to return to this loading type in a few moments. But for now, I'm going to put none here. Go ahead and click the add button and then click close. And you can see here, I know that this is eventually going to be a repeat load case because it has the red L in front of it. Now, within this load case, I can create a load item, And what I'm specifically looking for is the repeat load option over here. And here, basically the same way we had seen previously, I can grab my load cases and adjust their factors. So here I can see the major difference between a traditional load combination, the blue C, versus a repeat load case with the red L. And that's especially handy if you are, again, working on somebody else's model and you would like to interrogate it and see what is available in here. Now, just as a reminder, I'll probably mention this several times, but this is treated as a new primary load, and a second order analysis, such as a P delta analysis, will reflect the correct second order effects when using a repeat load case. Now, of course, we all know, and again, this is probably quite review for my experienced users in here, but we all know that creating a manual load combination could be tedious, especially if you have multiple load cases within your model. So for each of these primary loads up here, you can see that I've entered the loading type for each one. Now, what I'm getting ready to do next is I'm getting ready to generate some load combinations in this model. Now, the loading type will be used to associate the load case and the code definition of dead load, live load, wind load, etc. And this type of association needs to be done in order to make use of STAAD.Pro's facility for automatically generating load combinations in accordance with the code that you selected. So here I'm entering a loading type. You can see for dead load, I have dead load selected. My seismic, I have seismic load selected, and then live load, same thing. So what I'm doing right now is I'm going to get ready to generate my load combinations. So in STAAD.Pro Connect Edition in the Analytical Modeler, I can go to the Loading tab, go to Automatic Load Combinations, and tell the program I'm now ready to generate my load combinations. Within this dialog, I'm going to select the appropriate code that I will be using and the appropriate category. I'm going to select the AISC 360 10 version of the code, and I'm going to select the public option. Now, when I'm generating load combinations, I don't have to, there's no different workflow for traditional versus repeat. The main thing that's going to happen is you're going to select this checkbox if you're looking for repeat. You're going to unselect this checkbox if you're looking for traditional. Okay, so the workflow for generating repeat versus traditional is basically the same, and it's controlled by this checkbox here. So the icon's the same, but here you want to make sure you specify those options. Now, when you're using repeat load cases, you do have an option to include notional loads. This is specific for the AISC 360 direct analysis that we can perform in STAAD.Pro. It's a little outside the scope that we're going to be talking about today. Just note that you can include notional loads if you are performing a direct analysis in STAAD.Pro. But we're just going to create repeat load cases. I'm going to click here. I'm going to tell the program I want to generate loads. I have an option to preview the load cases that are going to be created. If I want to remove any, I can move them over to the discarded area before it officially commits them to the input file. If I would like to keep all of them, I can commit them to the input file and click on the Add button. Once I'm done, I can go ahead and click Close. And again, the program is going to help me out by putting the appropriate symbol in front of either repeat or traditional load combination. Now, whenever we generate load combinations in STAAD.Pro, we're basically utilizing some of the load combination generators typically that are installed with the program. And you saw when I used that command for, creating load combinations that I did select a code and a category. And I get a lot of questions about how do I know what is going to be generated for each one of those. So within STAAD.Pro, you are able to preview and edit or create your own load combination generators. To do that, we're going to go to the Automatic Combinations area, and you click on the Edit Auto Combination Rules. And here I can see all the rules that are installed with STAAD.Pro Connect Edition. So in my model, if you recall, I selected the AISC 360, and I selected the public load combination generator. I can see from this window that this will be generating an LRFD style load combinations. Here I can see that very clearly with their options. Well, what other options do I have available for the AISC 360 out of the box from STAAD.Pro? Let's start with general. If I went to the general load combination generator, that would be an ASD approach. We already saw that with public, that would be an LRFD approach. And we also have another option here for garage. This is another LRFD approach to load combinations, but we're going to see a significant difference here between the public versus the garage, and that's the factor on the live load. So depending upon the usage of your structure, you may be allowed to use a 0.5 factor on your live load versus a 1.0 factor on your live load. And that's the major difference between these two load combination generators. Now, if you're newer to STAAD.Pro or newer to the workflows for generating load combinations, it might be advantageous for you to come here and preview the different load combination generators that we have available within STAAD.Pro to select one that best suits your needs or your code requirements or the occupancy of your structure. So I'm already familiar with that. I already knew that I wanted to generate public load combinations, LRFD style, and I was going to allow the 0.5. But if you didn't know which one was which, you can definitely come here and preview it. And this will be definitely part of your workflow that you might want to incorporate, because once you generate load combinations, these are already in my input file. I'd have to go ahead and delete them if I change my mind and I want to go with a different load combination generator. So it's definitely a good idea to go with this. Now, let's go ahead and talk a little bit about the nomenclature that's included in this table, in case this is the first time reviewing it. The first thing you're going to see is include notional load. These are checkboxes. Again, notional loads are specifically for the direct analysis method. So let you know which portion or which items are kind of considered gravity load for the calculation of what that notional load will be. The next thing we'll do is we'll go ahead and take a look at the combination rule. So we have two different major options here. It says combine all cases together or separate combinations. Okay, so when you have something like dead load, live load, snow load, for example, these are all set to combine all cases together. That means basically if you have more than one load case set up as dead load, it means that they are added together in the resultant load combination. Now, all of our lateral load combinations are typically set to separate combinations. So if I have wind load in the X direction and wind load in the Z direction, let's take that example. If I was saying dead load plus wind load, it would create two load combinations when it includes a load case that says separate combination. So in that instance, I would say dead load plus wind load in the X, and then an additional load combination, dead load plus wind load in the Z. So wind load in the X and wind load in the Z are not added together in the same case in that scenario. So these are all the out-of-the-box load combination generators that are available. You can also have the option to create a new load or create a new category if, for whatever reason, you feel like you want to go down that workflow. Let me go ahead and close out of that area. The value of generating load combinations has a very clear understanding of the difference between traditional and repeat style load cases in the STAAD.Pro Analytical Modeler. Now what I want to do is I want to direct your attention to the STAAD.Pro Physical Modeler. So let me go ahead and close out of this model, and let's move on to our next workflow, which is to take a look at a physical model. And I have a physical model that's already been created. It's actually identical to the one we just saw in the Analytical Modeler. And let me just give it a moment to load and get me over to the Physical Modeler, and then we'll continue. Okay. And what we're going to be doing today is I'm going to be showing you how to manipulate your loads, or basically how to create load combinations in the STAAD.Pro Physical Modeler. Now, if you're new to STAAD.Pro Connect Edition or also the STAAD.Pro Physical Modeler, the Physical Modeler was added to STAAD.Pro when we went from V8i to Connect Edition. It's an area of the program where you can create physical members instead of creating an analytical model. So for example, you can see in my structure that I've created, say, a bottom chord for my trusses. In the field, this truss will be built from column to column. And you can see I was able to create a member that is continuous that entire length. Now, what the Physical Modeler does is it's basically a modeling tool within STAAD.Pro that allows you to create all of your model geometry, assign your properties, and now also create load cases and load combinations. Even some load definitions are now available in the Physical Modeler. Now, right now, it is a modeling tool, which basically means that the analysis and design still happens on an analytical model. What this is you'd create, if you wanted to use this workflow, you'd create a new physical model, you'd create your model geometry here, and then send it over to the STAAD.Pro Analytical Modeler. Through that process, we're going to build your input file for you for your analytical system, and then we're performing the analysis and design on that system. Now, new in STAAD.Pro Connect Edition version 22, update 5, we've added the ability to generate load combinations within the physical modeler. And that's what I wanted to also share with you today. By using the previous versions of the physical modeler, you were able to create manual load combinations one at a time, but you didn't have the ability to go ahead and generate it. And we've added that for update 5. So if anybody is using the physical modeler often, I'm definitely going to encourage you to grab that update as soon as it's available. Let me go ahead and show you what I have in this particular model. So in the STAAD.Pro Physical Modeler, we basically work with a main view window. We have our ribbon toolbar at the top of the screen, and then your data area over at the left-hand side. To get different spreadsheets within the data area, you're going to use the spreadsheet tab in the ribbon toolbar, and this will display whichever spreadsheet it is that you're working on at that moment. This is basically how you work your way or navigate your way through the program and then use these spreadsheets to add detail to your model. So you can see for my particular system, I've created some load cases. I've created a dead load and a live load case. And this model also has some seismic load cases. So I also have seismic load in the X and Z direction. These were generated using the IBC equivalent lateral force procedure. In addition to that, I also have a load group in my model. This is for seismic mass. This won't be included in my load combination, but it is used in my seismic definition to find the mass of my structure. So let's go ahead and take a look at the combinations area, and currently I have none. So let me go ahead and show you how to create a manual load combination, and then we're going to move our discussion into generating load combinations in the physical modeler. So this tab is how you are going to access your different spreadsheets if you want to see that in the data area. For creating information, what you're going to do is you're going to go to your model tab in the ribbon toolbar, and you can see I have a different area for loads. So how did I create those load cases? I created here and created load cases or load groups. If you're newer to the terminology used in the physical modeler, load groups basically refer to what we would call reference loads within the analytical modeler. Load cases refer to basically what we would call primary load cases, which appear in your load case details section in your analytical modeler. I'd like to make sure that terminology is clear. So what I'm going to do is I'm just going to create a manual load combination. So here what I'm going to do is I'm going to go to load combination and name it anything I want. I'm going to say dead load plus live load. I'm going to select which load types I want. I want dead load and live load. So any load case that you've already created in your model will be available from this drop-down list. And then you're going to fill out that filter first, and then you're going to come here and tell the program what your factors are. So I'm going to say 1.2 for dead and 1.6 for live. We also do have the option to add notional loads as well. But again, I'm going to just do some basic load combinations for today's session. So let me go ahead and click OK. I'm going to finish this off by clicking OK. And then we're going to see our load combination appearing over here. And of course, you can create as many manual load cases as you need for your particular model. Now, from STAAD.Pro Connect Edition Physical Modeler, we can create either traditional load combinations or repeat style load cases. And that is done or specified through your analysis options or analytical modeler options, I should call it. How do we access that? If I go to the data tab, I'm going to go to this options icon. And this will allow me to control several different features within the program, but one of the features within is how is your analytical model going to be created. This is where I'd go to tell the program, of course, I want to segment my members when you build the analytical model. I want to control how my surfaces are meshed when you go over there. And then also, I can tell the program what kind of load combinations I want to create. So analytical superposition means that I want to create traditional load combinations. Repeat primary load cases tells the program that those load combinations you see over here create repeat load cases. Since repeat load cases are more common and used for more analysis stuff, let me go ahead and select that. And of course, I can control my combination numbers of where I start from. 1001 is fine for me. So let me go ahead and click OK. I'm going to save, and let me go ahead and show you what I have so far in the analytical modeler. And then we'll come back here and I'm going to generate load combinations. So here, when I tell the program I'm going to go back to the analytical model, it builds my new input file from the information I have here. And it will be available once I get back to the analytical model. Now, if you're newer to the analytical modeling approach, what I do want to remind you of is that you do have to make the decision when you create your model if you want to go with an analytical modeling workflow or a physical modeling workflow, or actually, I should say, especially if you want to go with a physical modeling workflow. That decision is made when a new file is created. Now, if you do have a physical model and you decide at one point that you don't want to do a physical modeling workflow and you want to stick with an analytical model, you can say, drop my physical model, keep my analytical. I want to move forward just in the analytical modeler. That's not a two-way kind of operation, though, so you can't start with an analytical model and be like, yeah, I think I want to go with a physical model. We make that decision up front. So if you want to start your model, you're going to create that or specify that when you create a new model. Now, here I can see my load combination that I have created. It did create it as a repeat load case. I see load 1, I see its factor. Load 2, I see its factor. And again, I can verify that this is a repeat style load combination because of the red L that I see here. So again, repeat versus traditional happens in the analytical modeling options. Now, that was available in previous versions of STAAD.Pro Connect Edition. But what isn't available or will be available in Update 5 is the automatic load combination generators that we had seen in the analytical modeler. So I'm back in the physical modeler. I'm going to go to the automatic combinations icon. So I'm going to go to the automatic combination area, and you're going to see this looks very similar. Well, it probably doesn't look similar, but it makes sense compared to what the analytical modeler does, where you're going to select a code and a table. So I'm going to select the AISC 360. I have general, public, and garage again. So if you are familiar with the load combination generators in the analytical modeler, we use the same nomenclature over here, which is nice. I'm going to go with the public option, and I can choose which load combinations from that table I want to select. Okay. I can choose whether or not I want to use the load groups. For me, I don't have any load groups that would make sense to be included in a load combination, so I'm going to leave that unselected. You can create load groups if you prefer to create, say, reference loads for your dead load or live load or so forth. If you did that sort of thing, then you may need to check this checkbox. So even though I'm using an automatic load combination generator, it's very important to understand what's going to be created within the model. Of like, where did you put your loads and do those load combinations make sense? We can include a notional load available here. And I'm going to, again, leave that unselected. And let's go ahead and just click OK. And here are my load combinations. Now, with that analysis options, you saw where I could choose between traditional load combinations versus repeat style load cases. That's basically a global criteria. So you're going to set that, and then all of your load combinations are going to either come over as traditional or as repeat. So that's a global criteria that you are going to set up. Let's go ahead again. And whenever I'm showing something in the physical modeler, every time I add something, sometimes I like to go back to the analytical modeler just so I can show you what that looks like, because I know most people in here are probably very familiar with the analytical modeler and maybe slightly newer to the physical model. I like to show how that information is getting translated. Let's go back to the loading area. And here we can see all those load combinations that were created. This one includes the positive and negative effects of seismic load. And you can see seismic 1 and seismic 2. And of course, I could have more seismic load cases. I could have more additional information basically within here. Now let's go ahead and return to the physical modeler for this model one more time, because what I also wanted to show you is that you can also explore the load combination generators that are installed with the program. So I'm back in the STAAD.Pro physical modeler. I can go to the automatic combinations area. And if I clicked on this button while doing this option or this command, I go to manage rules. This takes just a second to appear on my screen, so just bear with me. There it is. I can see all the rules that are available. And of course, it's going to default to the one that I currently have selected in the pull downs, which is the AISC 360 public option. And this is definitely an area where you can go ahead and see what will be created for each load combination generator. And hopefully you can see that these have basically the same nomenclature that we do. What you're going to do is you're going to double click on this pane, and then it's going to appear in a new tab over here. There we go. So you can kind of see what will be created. I'm looking for the general. There we go. So here I can see again the ASD style load combination generator. The public is an LRFD with a 0.5 factor on live load. And then the garage is LRFD with a 1.0 factor on live load. Now within this particular area, if you go to codes and table, you can create your own custom codes and your own custom tables if you needed to. And you could basically create that additional information just like you can in the analytical modeler. So this is a great place to go if you want to go ahead and review that information again before you create those load combinations. Now, it is a little easier to delete information from the physical modeler if you decide that maybe, I don't know, some of these load combinations you don't want. You could just highlight their lines within the spreadsheet, delete them, and every time you go back to the analytical modeler, it will go ahead and rebuild your input file. Okay. Now that we've gone through those main topics, I have a bonus topic that I added on just in the past few days that I thought might tie in nicely to what we were doing today, since I was showing you a little preview of the load combination generators that are available in the STAAD.Pro physical modeler. I also wanted to point your attention to our new ability, which might tie in nicely to the loading topics that we did today, to create seed files within STAAD.Pro. So what I'm going to do is I'm going to go ahead and close down my model that I was currently working on. So new in STAAD.Pro Connect Edition version 22, update 5, you will have the ability, which I'm super excited about, to use seed files as basically a template for creating new STAAD.Pro models. Now, there's nothing super special about this seed file. It's basically a STAAD.Pro model that already has information in its input file. You don't have to like set it up as like a template or specific seed file. You can just create basically a STAAD.Pro file with information that you use often and you want available in new STAAD.Pro models. So you can maybe save yourself some modeling steps. So I would create my seed file with information that I use often. Things like load combinations or load cases that I use all the time that I don't want to necessarily recreate. Now, to help you in that process, we do install with this version of the program several sample seed files in case you were interested. Again, I'm calling it a seed file in quotes because it's basically just a STAAD.Pro model that you can reference in when you're creating a new model so that you can save yourself some modeling steps. And again, I would use this workflow for common data that I use all the time. Okay. So we can do this for both if you're creating an analytical model and a physical model. So I'm going to show you both of those workflows again to kind of cover everybody's workflows that you might be experiencing. So what I'm going to do is I'm going to start by creating a new model. And let's start with the analytical system. Okay, so I'm going to create an analytical model. I'm going to call this analytical model with seed. Okay. I can save it anywhere I want. And then what you're going to see is you're going to see a new option down here for a model seed file. Okay. So what I'm going to do is I'm going to click on the browse button. And immediately it's going to take me to the place within my system where these seed files are saved. So when you install update 5, you're going to get some sample seed files installed on your computer. You can click on that browse button to see where they are, but they're basically put in your C documents area. We have a sample for seed files, both English and metric units, both for physical and analytical models. Now for myself, because I wanted to explore how to do this, I created my own custom seed file that I was interested in. And it doesn't have to be saved in this area. It can be saved anywhere you want. So I created my own seed file here, and I called it AM seed. I might consider putting a more description, like I put AM seed with LRFD combos, something like that. Might be nice to add a little bit more information here than I did, but you can name it anything you want. And again, it's just a STAAD.Pro model that already has information in its input file. So let's go ahead and click the open button. It's grabbing that seed file. And then when I click create, what it's basically going to do is it's going to read in that seed file, basically copy its input file and make it available in this file. So my particular model had some load cases already in it, had some load combinations, and I think that this one I put some load envelopes in it as well. So if I go to the loading area, again, this is a blank brand new model that I just created. It grabs that information for me. So I know for this particular model, I'm going to have some seismic load, wind load, dead load, and line. Now, again, I'm going to ask you to, use caution if you're using this, because this should have common data that you're using in whatever model. That's why I said when I name it, you might want to name it something descriptive of like seismic load with wind load and LRFD, something like that. So you know what this represents. But in this particular model, I had my seismic load, wind load, dead load, and live load. They were empty load cases. And then I also had generated some LRFD style load combinations and some ASD style load combinations. Okay. If I went to the envelopes area, I would also see that I had created both a strength and service load envelope. If I went up here, I can see that I also created a mass load case. I did put some load items within this load case, which you are able to do. Typically, when you close your model and you have, say, a blank load item in it, it doesn't actually write it to the input file. The way you can get around that is you can put this directly in your input file if you feel comfortable with that workflow. So here I'm kind of I'm ready to go. So what I can do is I can start creating my model geometry for this structure. I know that these are load cases that I'm eventually going to want. And I maybe save myself some modeling time. Now, again, you're just going to want to use care when using this. Make sure these load cases are appropriate for whichever system you're going to be creating. So here I'm kind of I'm ready to go. I would use this for I did it for this particular model since we have a loading focus today. I used this to create some load cases. I actually yesterday created a sample model where I put in perform analysis and change command after each of my seismic load cases, and then that came in correctly. So that was kind of cool. If you're doing a model that has seismic loads with, say, orthogonal effects, where you have multiple permutations of load that, again, maybe you use often, you can now create C files, which I think is a huge advantage for you. I know in the past I've had sample models where have common loads that I used before, and I usually just kind of copy them and paste them in my input file. And now we can do that automatically when you create a new model. Again, available in update 5. Now you can do that for analytical model. We also have the ability for a physical model. So let me just go ahead and share that workflow with you. So here I'm going to create a new model. Let's call this PM with seed. There we go. I tell the program I'm working on a physical model. This is where you make that decision, physical versus analytical. And we can grab our seed file. Now, every time it automatically goes to the sample seed files that we provide to you. Actually, let's go ahead and take a look at those. So you can see we have analytical and physical. You can see here we gave you some information that might be helpful. Physical and analytical of things that we already have in those. Again, I created my own that I was interested in. Let's say seed PM is what I called this one. Just grabbing that, go ahead and say create brand new model, bringing me over here. And then you can see, let's go to the spreadsheet tab. You can go to load groups. You can see I created a load case, or a load group, I should call it, for seismic mass. I created some load cases, dead load and live load. You can see this model, actually this model already has an IBC seismic definition in it. Again, be careful when you do that, because your response modification factors, importance factors, those will be kind of taken in from whatever's in that seed file. So this model already has some seismic load cases, and it already has my load combinations. I believe also that it brings in my analysis options, and it's already set to repeat primary load cases. If you notice from the previous model, the default was to go up to analytical superposition. So it grabbed that as well. Okay. So already I don't have any model geometry. If I did have things like grids, it would bring that in, other information as well. So again, this is just a brand new model that I just created. You all saw that. And if I go to the loading area, I can see that I already have model data here. In fact, this one even has some load items. This one already had, again, like a seismic definition within it. And we have our masses. So some of the things I showed you are available already. Some of them will be available in update 5. Again, that will be any day now. We do have some other exciting things coming out in update 5 as far as loading goes. Let me go ahead and just mention those very quickly. For the analytical modeler in update 5, you will be able to generate wind loads for the ASE 716. So we're updating our wind code on that. That's super exciting. So that'll be available in update 5. For the physical modeler, we've added the ability to generate automatic load combinations. We've added the ability to model notional loads. We've added the ability to generate wind loads in the physical modeler on the ASC 7.